Hello everyone. In the previous video, we discussed many of the Atom's features. One of the main features of Atom is closed-loop automation. We had discussed this in the automation and orchestration video. But let me remind you what exactly it is. Remember, we had spoken about the recipe and how we carefully taste it to make sure that all ingredients are present in the right proportion. And if we see there is something lacking, we take corrective actions like adding salt or chili. Similarly, the network orchestrator with closed-loop automation capability has to continuously monitor the network to see if anything has gone wrong. If it senses any deviation from the expected behavior, it has to take corrective actions. With Atom in the network, the closed-loop automation works in a very similar manner. It uses the power of telemetry data, applying analytics on top of it, correlating it with the policy specified in Atom, and thus taking remediation actions to provide service assurance. Atom can do this across multiple vendor networks and across different domains like data center, branch, campus, and cloud in service providers and enterprises. Let's try to look at some of the real-world use cases where closed-loop automation and Atom can play a very crucial role in creating smart and self-healing networks. Managed Service Provider or MSP. A managed service provider is the one who manages an enterprise network infrastructure or the end user. In this example, we are taking an MSP who provides branch office connectivity. This includes customer premise equipment or CPE provisioning. The CPE would have routing, security, and other functionalities. The CPE would then get connected to the service provider WAN through technologies like MPLS. We had discussed how that works in the WAN and the SDN video. Imagine a large MSP who handle hundreds of thousands of such remote devices. Each branch CPE may be a different vendor equipment, and the routing and security devices may or may not be a single device. The MSP service desk goes through a manual process of configuration, notification, recording, prioritization, troubleshooting, and escalation process. This tedious process is prone to human errors and has its limitations. Atom, with its closed-loop automation powered by orchestration, workflow, collection, correlation, and remediation capabilities, helps in reducing provisioning time from hours to few minutes and reduces troubleshooting effort due to an auto-healing feature like closed-loop automation. Financial service provider. A financial institution like a bank considers IT network connectivity key to their success. Any loss of data due to network downtime or network errors will have a huge impact on their business and the economy. Such enterprises are business critical, and low latency and high availability are the benchmarks for managing their IT infrastructure. But networks are vulnerable, and faster resolution is decisive in such businesses. An enterprise may have multiple domains like branch, campus, and data center. The troubleshooting efforts needed in each domain will vary depending on the key performance indicators. Manual troubleshooting techniques would be time consuming. In Atom, the closed-loop automation with its analytics and telemetry capabilities provides actionable insights into these domain-specific network events and can take remediation steps such as managing the latency by various means within the order of few milliseconds. This scenario would guarantee service assurance and high availability of networks. Application delivery. We know that new applications are flocking to the industry every day. The applications are deployed in data centers, and each application requires a differential treatment in the form of end-to-end QoS from the data center to the edge of the network, where the end user, like you and me, access the application. An application handling video calls will need better QoS than an application handling email. So there is a definite need to automate the configurations to network devices during the deployment or access to the applications. Closed-loop automation can act as a bridge between the application and the network. Let's say the application deployment relays a trigger to Atom. Atom has an open architecture and can take requests from external devices or applications, which in this case will be the trigger to its closed-loop automation system to configure all the network devices. A successful configuration results in closing the loop between the application and the network. Telecom service providers. With 5G around the corner, mobile or telecom service providers have a need to transition into smart networks. They need to support a wide range of 5G use cases. While we know most of the action happens in the data center as the core of any network is deployed there, including the applications serving the users. But what we also need to realize is that all the data from the end user reaches the data center through an IP network backbone. The cell sites or towers, which is your mobile's first point of contact in the mobile network, will have routers deployed in them. These routers will be connected to the data center, thus enabling the connectivity between the radio and the core network. It is expected that hundreds of thousands of cell sites will be needed for densification to provide seamless connectivity for mobile users. Manual configuration and troubleshooting of networks of this magnitude are cumbersome and practically impossible without an automated solution. Atom, with its scalable architecture, can handle hundreds of thousands of such devices. While Atom's service models and workflow will help in mass-scale provisioning, it's a closed-loop automation feature with its analytics that will help in faster remediation of issues. It will help in ensuring 100% uptime, thus mitigating potential subscriber churn and loss of revenue. Multi-vendor SD-WAN deployments. We had discussed about SD-WAN in our WAN and SDN video. We saw how SD-WAN allows enterprises to use MPLS networks and internet services for branch connectivity or for specific applications. A multi-vendor strategy is core to any business. It generally gives more power to the organizations such that they are not dependent on a single vendor for any feature requirements they have. But every SD-WAN vendor has a proprietary solution. Need for multi-skilled staff, complexity in troubleshooting the network, and multiple integrations into their existing ticketing systems force them to stick to a single vendor. A solution like Atom can save the day. Atom can act as an overall orchestrator for a multi-vendor SD-WAN solution. It can interact with both SD-WAN controllers and onboard their CPEs. From a troubleshooting perspective, it is possible that telemetry information coming from each SD-WAN vendor will be different. Atom can handle this complexity and feed into its closed-loop automation to rectify issues within the WAN infrastructure. For example, if bandwidth management is a use case, Atom can handle that. Using closed-loop automation, it can monitor the bandwidth usage and push policies through multi-vendor SD-WAN controllers as needed, thus ensuring service assurance. This can also be integrated to Atom's workflow automation to bring in approval chains if required. Let's take a quick recap on what we have discussed so far. We primarily discussed how Atom and its closed-loop automation capability plays a critical role in IT networks and how it can help in reducing troubleshooting efforts in all the real-world use cases we discussed. These were some of the sample use cases that Atom can support. There are many more customer use cases, some of which we'll discuss in the next video. Thanks for watching.